Okay, now we will talk about Industrial 4.0, which is some kind of chapter 7 that we will find. It's a bit long, it's meant for the holiday reading, but we'll kind of go through it. So, with that, there's some topics, key learning point, a few key learning points that you might want to kind of remember. So I talk a little bit about introducing the Industrial 4.0. The key learning points about Industrial Revolution and the Industrial 4.0 is to grasp the evolution fundamentals of the 4.0, building blocks of 4.0, some CPS, big data, cloud computing, and smart industries, Industrial 4.0 technology, digital thread and twin technology, sustainability in 4.0, some of the challenges, future trend, and implementing this 4.0. So with that, what is Industrial 4.0? Basically, is to set Singapore manufacturing industry in a large company, either large, small, logical, equipped with Singapore facilities, some advanced manufacturing technology and wrapping in return. So why do you want to learn this in FM? Because this is basically following the industrial trend. FM is a little bit behind things like maybe car manufacturing industry, probably about 5 to maybe 10 years. So knowing the trend of Industrial 4.0 will know the trends of the building, right? So this is Industrial 4.0, and of course we can talk a little bit more in detail. 4.0 is also known as the 4th Industrial Revolution, in the integral part of the digital technology into manufacturing processes, creating smart factory and building previous industry revolution, leveraging technologies such as artificial intelligence and Internet of Things, big data analytics and additive manufacturing. So key component of 4.0 is IoT. We talk a lot of IoT. How is it like embedded sensors, software, and also kind of data exchange over the internet. So in the world, we actually has enabled machine learning and communicate collaboration with each other, leading to enhanced efficiency and productivity. So big data analytics is also part of 4.0. Big data analytics involved in large volume of data to uncover the insights and patterns in the industry. So Industrial 4.0 can leverage big data analytics, optimize processes, predict maintenance need, and make the data-driven decision for improved performance. So artificial intelligence, AI such as machine learning and cognitive programming becomes a task where you require human intelligence and manufacturing. You enhance and automations and predict maintenance and facilities control. So for robots and robotics automation, the robots plays an important role in 4.0 by automating some of the repetitive tasks and increase some of the positions, improving the manufacturing environment, advanced robot equipped with AI sensors along with human sensors. So additive machining is basically known as so like 3D printing and label complex object layers and layers. These technologies offer manufacturing design flexibility, some waste reduction, improving the production cycle times compared to the traditional method. So with that, what we want to learn a little bit about Industrial 4.0 is it enhance productivity. So basically, we streamline the process, reduce downtime, improve the waste management, increase efficiency. So this enhancing efficiency. The other point is improve the quality and customization. So with real-time data, you're able to analyze things faster. Manufacturer can identify and address quality issues faster and ensure that the higher product quality. So in addition, Industrial 4.0 enables the mass customization of certain facilities. So cost reduction is another key point of optimizing process. So waste reduction enhance resources and helps the industries to be more competitive. So sustainable practice, Industrial 4.0 also promote sustainability and enabling the energy efficiency manufacturing and reduce kind of waste and minimize the environmental impact. So 3 of Industrial 4.0 is Industrial 4.0 is connected to somehow advanced manufacturing. Advanced manufacturing adopted and leveraged the latest advancements of mechanics like physics and chemistry together with computing, right? So that it can actually enable the control technology to build it to be faster, better, smaller, more accurate in terms of nano engineering, nanotechnologies to sensor technology, right? So the paradigm shift in the industries is where manufacturing since the early days of industrial has undergone several paradigm shifts. Broadly, manufacturing has moved from mass production to mass customization. So every part is kind of customized. So for example, like cars is kind of customized in a way. Your phone is customized, your product is customized, your building and rooms are customized, right? So it involves a more labor-intensive sets of mechanical process in the traditional part of it to a more information technology process, which is the advanced part of it. So in the mass production is in terms of economics of skills. For mass customization is economics of scope, while personalization is value differentiation. So we need to improve our value in order to sell more and better. So with that, intelligent manufacturing is also to implement intelligence based on the intelligence production that can automate and change environment with a various process requirement. The minimum interval from human beings. So less and less human beings are able to touch, sense, but more of the control piece of it. Of course, it combined with some intelligence of the people to process machines so that impact the overall economics, right? Or the economics of the things. Overall, it try to focus on some AI advancements of sensing, control, optimization, and knowledge management. So with that, intelligent manufacturing, sometimes we call IM, focuses on the manufacturing resources, improve business value and safety, and reduces waste both in the floor, back office, operation, while the customers have a stronger and stronger demands, right, in terms of delivering and quality. This is achieved by manufacturing execution system, sometimes called MES, intelligent devices and machine-to-machine communication, meaning machine can talk to machine itself, and the data analytics for the production and the facilities itself. So with that, right, we also want to talk a little bit of intelligent manufacturing, which is called IM, right? And the essential thing is data. So data actually has a sequential solutions to complete the intelligent manufacturing system. You gather data together, give the manufacturers a real-time information, or the person that's involved in real-time manufacturing about their processes, so that they can move easier and easily forecast trend and perform root cause analysis. This information guides future production, helps prevent defects and recalls, so much more. So the other part is smart manufacturing. Why do we want to talk about smart manufacturing? It's because smart building is also a broad base of manufacturing in the goal of optimization, concept, generalization, production, and products transaction involving computer control and adaptation. So smart reference in the creation of the data throughout the product lifecycle. The goal is to create flexible manufacturing process that responds rapidly in the change of a low-cost environment. So with that, just want to share some characteristics. So digitalization of every part of the manufacturing and prizes the interoperability, enhancing productivity, right? So you connect device to device, you distribute intelligence for real-time and flexible production in small batches. So collaborative smart chain management with fast response integrates optimal decision for energy and resource efficiency. So advanced sensors like big data through product life cycle achieve a fastest kind of innovation cycle. So with that, we want to talk about some big data processing. So big data analytics is also defined as complicated process when you're managing your supply chain, and big data is able you to shift from reactory predictive targets to a more efficient process and performance. Some robotics, as you mentioned, with smart machining operating autonomously, can also communicate directly with themselves and manufacture some of the systems itself. So robotic system can also work with human and co-assembly of the task itself. So advanced robotic can also complete complicated works and initially programmed for what we have in terms of artificial intelligence and have them do the machine learning. The flexibility of this machine allowed them to rapidly change the design and innovation. Industrial connectivities of devices and services is also leveraging on the capability on the internet. Because of better broadband, increase of integration of data and storage, we are able to actually receive and connect devices. So ambiguous use of mean data throughout the product chain, right, connecting the manufacturer to the customers and supply becomes much faster with cloud software, smarter and higher configuration of computer resource. So with that, we'll touch on a little bit more point on industrial connectivity and services. This allowed the service networks and other storage to create to be released rapidly, and then enterprise integration of platforms enable you to collect broader data from the machines, which can track work flow and machines and metrics. So open communication between the devices and network could be achieved by connectivity, includes everything from tables to machine, and now the efficiency is well supported by the business model, including some mass customization.